Now that we've established the angles both in degree measure and in radian measure on the unit circle, we are going to turn our focus to establishing where these XY pairs come from on the unit circle, okay? So starting on page 4, we are going to concentrate on the coordinates at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, okay? So again, what you've got to realize here, what is our goal, okay? We are dealing with the unit circle. It is a circle that is in the XY plane. It is centered at the origin. It has a radius of 1. So every single point that is on the unit circle is located somewhere in the plane. Every point on the circle has an x coordinate and a y coordinate. And so for the angles of interest on the unit circle, we are going to go and figure out the exact values of these x, y coordinates for every angle on the unit circle, okay? So we are going to start with these 4 angles, okay? And then we'll work our way through the remaining angles on the unit circle, okay? So let's take a look at page 4, okay? So here it says we're going to look at the coordinates, XY pairs, at the angles pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, okay? So actually, what we're going to do here, if you look at this page, there's some words up here to explain what we're going to do, and then most of this page is an enlarged unit circle. All it has on it are the angles in radian measure, okay? We are going to focus on pi over 6, and then once we've established the coordinates at pi over 6, it'll be a similar method for getting the coordinates at 5 pi over 6, 7 pi over 6, and 11 pi over 6 because they are related to the coordinates at pi over 6. If you notice next to pi over 6, here's the point on the circle, okay, corresponding to the angle of pi over 6. I have a letter A right here. This letter A is talking about this point on the unit circle at pi over 6. So when we read the information above, it will reference this point A. So at least you know what I'm talking about. Okay. All right. So let's go up to the top here and start reading, and then we'll do some drawing on the unit circle here. All right. So if a diagonal is drawn at the pi over 6 radian angle, which is the same as a 30-degree angle, it will intercept the circle at point A. From point A, a vertical line can be drawn to the x-axis to create a 30, 60, 90-degree triangle. The relationship between the sides of a 30, 60, 90-degree triangle will help establish the coordinates x, y of point A. Okay, so let's go down and look at the unit circle and try to make sense of that statement, okay? All right, so here's our unit circle. We're going to concentrate on the angle pi over 6. We know pi over 6 radians is the same thing as 30 degrees, okay? Our goal is to figure out the coordinates of point A, okay? What's the x coordinate? What's the y coordinate, okay? All right, so what that statement was saying, okay, it referenced this 30, 60, 90-degree triangle, okay? So we're going to draw in a triangle here. This is how we're going to do it, okay? A triangle has 3 sides, okay? So we're going to start at the origin, okay? So this is the point 0, 0, because we're in the xy plane. The first leg of the triangle, we are going to get by drawing from the origin to the point on the circle. Okay, so I am drawing my side like this. Okay, so we want it to go from the origin to the point on the circle. Okay, so it's going to look like that. Okay, now keep in mind what I just did. Okay, this is just, like I said, this is just one side of the triangle. Okay, look at this distance. I drew from the origin, the center of the circle, to a point on the circle. That's the radius, okay? That's the radius of the circle, the distance from the center to a point on the circle. This is the unit circle, so the radius is 1. That means the length of this side of the triangle is 1, okay? All right, now to get the other 2 sides of my triangle, okay, the next leg is going to come from starting here at the point on the circle and drawing a vertical line downward to the x-axis. Okay, so like this. Okay, I'm going from the point on the circle straight down to the x-axis. Okay, and then the last side of the triangle comes from drawing right here, from the origin to where this point, where this leg right here meets the x-axis. Okay, so from right there. Okay, so there are my three sides of the triangle. Okay, and notice since this leg right here, I drew straight down from the point on the circle straight down to the x-axis, that created a right angle. Okay, so this is a right triangle. Now, the other thing to notice, okay, we drew this particular angle, okay, through the pi over 6 mark, okay. Pi over 6 is 30 degrees, okay, so this is a 30-degree angle right here, okay, and we know that there are 180 degrees in a triangle, so if we have 90 degrees and we have 30 degrees in our triangle, that means this remaining angle has to be 60 degrees. Okay, so this is a 30, 60, 90 degree triangle. Okay, so what we're going to do, this is one of those special right triangles we learned about. We are going to try to figure out the lengths of the two remaining sides on the triangle. We already know the length of the hypotenuse. The length of the hypotenuse is the radius of the unit circle, so it's 1. Okay, but we are going to go now and we are going to try to figure out what the length of this side is and what the length of this side is. Okay, and we will talk about why we need that. Okay, all right, so let's go back and revisit the relationship in a 30, 60, 90 degree triangle. Okay, so I'm just going to draw some random triangle. It won't be to scale. Okay, so in a 30, 60, 90 degree triangle, okay, you have something that looks like this. Okay, the way it works, there's a short side, there's the hypotenuse, and then there's the medium side. Okay, so the short side is always the side across from the 30-degree angle, and so you're going to figure out what the length of that side is. I'm going to call it A. And then once you know the length of the short side, you know the length of the hypotenuse is double that. Okay, so it's going to be 2A. And then the length of the medium side, the side across from the 60-degree angle, it's the short side times the square root of 3. Okay, so this is the relationship in a 30, 60, 90-degree triangle that you learned about with the special right triangles. All right, so if we come back down here, okay, that's going to help us figure out the lengths of these other two sides, okay? All right, so we know the hypotenuse. That's all we have to work with. We can get the short side. Remember, the short side is going to be the side across from the 30-degree angle, okay? We know that whatever the short side is, the hypotenuse is double that, okay? So since the hypotenuse is double the short side, all we need to do is cut this hypotenuse in half, and that will give us the length of the short side. Okay, so since the hypotenuse is 1, that's going to tell us the length of the short side, which is the side across from the 30-degree angle. That length has to be 1/2. Okay, again, you could look at it on the flip side. If you take the short side, which is 1/2, and you double it, you get 1, the length of the hypotenuse. Okay, all right. So now that we know the length of the short side, we can establish the side across from the 60-degree angle. All you have to do is take the length of the short side and you need to multiply it by the square root of 3. Okay, so you can make this a fraction by putting it over 1, multiply across the top and multiply across the bottom. The length of the the length of the medium side, the side across from the 60-degree angle, is the square root of 3 over 2. Okay, so now we've got the length of all three sides. Okay, why? Why is this helpful? Why am I doing this? Okay, well, now that I've got the length of all three sides, this is how I'm going to get my coordinates at A. Okay, so think about it. We're in the XY plane. Okay, if I'm traveling from the origin to the point A, how do I get there? Well, think about it this way. How do I travel in the X direction? Well, I'm going to have to go from the origin and I'm going to have to go this distance. Okay, and so that is a distance of the square root of 3 over 2. Okay, so my X coordinate is going to be the square root of 3 over 2. Okay, so that brings me to right here. Okay, and then I have to travel up so far. Okay, so then I have to travel this distance, and then I reach that point A, okay? So my y coordinate is going to be this blue distance, which is 1/2, okay? So there are the coordinates of point A, okay? You can go back to the complete unit circle. You can check out the coordinates at pi over 6 or 30 degrees, and there they are, the square root of 3 over 2, 1/2. Okay, so now you can see where those coordinates came from, okay? All right, I'm just gonna color code this for your notes. Okay, so remember the x coordinate is this yellow distance and the blue distance is the y coordinate, okay? All right, so we've got our coordinates at point A, which is the point corresponding to pi over 6 or 30 degrees. Okay, and I told you once we had these coordinates, okay, this would help us with 5 pi over 6, 7 pi over 6, and then 11 pi over 6, okay? So let's turn our attention to 5 pi over 6, okay? You can draw a triangle here in a similar fashion, okay? So what you would do is you would start by, drawing the first leg of the triangle. It's going to go from the origin to the point on the circle. Okay, we're interested in 5 pi over 6. By the way, do you remember what 5 pi over 6 is in degrees? Okay, if you want to do the conversion or flip back in your notes, 5 pi over 6 radians is 150 degrees. Okay, just so you know. Okay, so that's the first leg of the triangle. Okay, actually, let me put this in a different color here. Okay, so I can keep the triangles in different colors. Let's use red here. Okay, that way you can tell the difference. Okay, so here we go. Here's the first leg of the triangle from the origin to the point on the circle. Okay, all right, so then we know that distance is 1. Okay, again, we have the distance from the center of the circle to a point on the circle. Okay, that's the radius. Okay, so this distance is going to be 1. The next leg comes from drawing straight down. So take the point on the circle, draw straight down. Okay, and then here you go. Okay, like that, okay? And then the last leg comes from drawing from this point back to the origin, okay? And there it is, okay? And again, because we drew straight down from the circle to the x-axis, this creates a right angle, okay? Now the thing is, okay, we're dealing with 5 pi over 6, which is really 150 degrees. Okay, remember 5 pi over 6 or 150 degrees, it is in standard position. So what that means is the initial side of the angle has to coincide with the positive x-axis. And so you start rotating counterclockwise, and that is 150 degrees. Okay, so since there's 180 degrees in a straight angle, so from here to here, okay, you can take that difference, 180 minus 150, and that's going to give you the measure of this angle. Okay, that's going to be 30 degrees. Okay, so since this is a 30-degree angle, that makes the remaining angle 60 degrees. Okay, so you can do the same kind of thing at 5 pi over 6. You get the same kind of 30, 60, 90-degree triangle. Okay, so the hypotenuse is still 1. Okay, so that means when you look at the lengths of the other two sides, they're going to work the same way. The length of the side of the triangle across from the 30-degree angle is going to be 1/2. The length across from the 60-degree angle is going to be the square root of 3 over 2. Okay, so it works the same way. Okay, again, what are we trying to do? We're trying to establish the coordinates at 5 pi over 6. Okay, what's the x coordinate? What's the y coordinate? Okay, because we're in the xy plane. This point is located specifically somewhere. Okay, now think about it. This is not the same as point A. It's a totally different point on the circle. Okay, so it can't have the same coordinates. Okay, because then that would be the same point. Okay, so what you've got to remember here, what's the difference here? Okay, well, point A is in quadrant 1. Okay, this triangle, everything we did with point A was in quadrant 1. Now this red triangle is in quadrant 2. Okay, that changes things. Okay, why do the quadrants matter? Okay, well, remember, we're establishing coordinates, x, y pairs. Okay, so remember, in quadrant 1, your x values are positive and your y values are positive. In quadrant 2, okay, you've got negative x values and positive y values. Okay, because remember, if you look at your xy axis, okay, remember, if you're traveling along the x-axis in quadrant 2, okay, you're to the left of the origin. Your x coordinates are going to be negative, okay? If you're traveling along the y-axis in quadrant 2, okay, your y values, you're above the x-axis, so that you're going to have positive y values, okay? So in quadrant 2, your x coordinates are negative, your y values are, or sorry, your x values are negative and your y values are positive, okay? In quadrant 3, what happens? Okay, you look at quadrant 3 is right here. You have negative x values and you have negative y values, okay? So they're both negative. And then if you go to quadrant 4, which is over here, okay, quadrant 4, okay, if you look up, this is where your x-axis is in quadrant 4. You have positive x values and you have negative y values, okay? So that's going to give us the difference here, okay? When you are trying to come up with the coordinates at 5 pi over 6, okay, yeah, you've got to travel this yellow distance. So to get from this point, to get from the origin to the point on the circle, you have to travel this distance along the x-axis, okay? This distance is the square root of 3 over 2, but your x coordinate is negative in the second quadrant. Okay, so this is going to be negative square root of 3 over 2. And then when you look at how you have to travel from this point to get to the point on the circle, you've got to go up this distance, the y distance, which is 1/2. Okay, your y coordinate here is going to be positive. Okay, so here are the coordinates of this point. Okay, so this point on the unit circle at 5 pi over 6, which is 150 degrees, the coordinates are negative square root of 3 over 2, that's the x coordinate, and the y coordinate is positive 1/2. Okay? All right, so you could do the same kind of thing. Okay, you could go to 7 pi over 6 and draw a triangle. You could go to 11 pi over 6 and draw a triangle. And, you're going to get similar looking 30, 60, 90-degree triangles. Okay, I'm going to pause the video. I'm going to go ahead and draw those triangles in, and then I'll resume the video. All right, so I've drawn in the two triangles at 7 pi over 6 and the other at 11 pi over 6. Okay, so they look pretty much identical. Keep in mind that if you're working at 7 pi over 6, 7 pi over 6 is equivalent to 210 degrees, okay? So make sure you understand why this is a 30-degree angle, because again, if you're starting all the way around, okay, because you know 7 pi over 6 has to be an angle in standard position. So if you're starting from your initial side and you're going all the way around, that's 210 degrees. You have to subtract out the half the circle, the top half of the circle is 180 degrees. So that difference, 210 minus 180, gives you 30 degrees right here. Okay, so that makes you form a 30, 60, 90-degree triangle. You again use the relationships in a 30, 60, 90-degree triangle, keeping in mind that this distance or this leg on the triangle from the origin to the point 7 pi over 6 on the circle, that is the radius of the unit circle. That's a distance of 1. Okay, so that means the short side right here across from the 30-degree angle is 1/2. And then the other side across from the 60-degree angle is the square root of 3 over 2. Okay, matches, it shares that side with the red triangle. Okay, so when it comes time to come up with the coordinates at 7 pi over 6, okay, you can easily get them. Okay, so to go from, to travel your x distance, it's going to be this yellow distance. It's the square root of 3 over 2. But remember, you are in the third quadrant now. Okay, in the third quadrant, the x coordinate is negative. Okay, so this is going to be the negative square root of 3 over 2. Okay, and then to get to your point on the unit circle, okay, you go from the origin, travel the yellow distance, and then you travel this blue distance down. Okay, so that's 1/2 units. Again, you're in the third quadrant. Okay, so the y coordinate has to be negative. Okay, so the coordinates of this point at 7 pi over 6, have to be negative square root of 3 over 2 and negative 1/2. Okay. All right. Lastly, okay, we'll do this green triangle. Okay. So this is the triangle that was drawn for 11 pi over 6. Okay. So if you're thinking in terms of 11 pi over 6, that is equivalent to 300 degrees. Oh, let me put this right here. Let me move it so I have some room. Okay. So 11 pi over 6 is 300 degrees. Okay, so again, if you're thinking about how do you get this, you establish this 30-degree angle, okay, 11 pi over 6 has to be drawn in standard position. So you would start from the initial side and you would rotate all the way around to here. That's 300 degrees. There's 300 and there's, oops, sorry, I got that wrong. It's 330. What am I thinking? Okay, hold on a second. Let me correct myself. Okay, 11 pi over 6, sorry, is 330 degrees. Okay. So there we go. So when you're drawing this guy in standard position, okay, so you would start with the initial side, you rotate all the way around. That is going to give you 330 degrees, but there's 360 degrees in a full circle. So that means this difference has to be 30 degrees. Okay. So here's your 30-degree angle, here's your 90-degree angle. The remaining angle has to be 60 degrees. Okay. We know the distance from the origin to the point on the circle at 11 pi over 6 has to be 1, the radius of the unit circle, okay? So you can establish the lengths of the other two sides, okay? So this side right here, this side across from the 60-degree angle is going to be the square root of 3 over 2. The length of the short side is 1/2, okay? So you get the same type of coordinates. So you can go ahead from that, you can write down the coordinates at 11 pi over 6, okay? So we know to get from the origin to the point on the circle right here, you have to travel the x distance, okay, which is the distance from the origin to right here, okay. That yellow distance, it shares that same distance with the blue triangle. That is the square root of 3 over 2, okay. Now remember, this triangle is being built in the fourth quadrant, okay. So in the fourth quadrant, your x values are positive, okay. So this is correct. The x coordinate is going to be the positive square root of 3 over 2, okay. And then to continue on from this to this point, okay, you're going from the origin to right here, okay, and then to get to the point, you've got to go down this many units, okay, that's a distance of 1/2, okay, that's your y coordinate, okay. We know in the fourth quadrant, the y coordinates are negative, okay, so the y coordinate here will be negative, okay. So the coordinates of that point at 11 pi over 6, okay, the coordinates are going to be this positive square root of 3 over 2, negative 1/2, okay. So there are the coordinates at each of those 4 angles, okay. You can return to the unit circle on page 1 and you can confirm that's what they are, okay. But now you actually see where they came from.